Okay, today we going to solve problem with binary tree data structure. So this is a problem here. So let's read the prompt. Three pathfinders. Drive function pathfinders that takes in the roots of a binary tree and the target value. The function choose returns an array represent a path to the target value. If the target values is not found in the tree, then return null. You may assume that tree contains unique values. So what we're gonna do here, like, okay, this is an example I already write here. I already have write it down here. So we're gonna have like the roots, right? Let's say I have the root A, and then the binary tree have a left and right. So I presume on the right side we have the root, uh, the child B, node B, and then the B have two children, D and E on the left and the right. And another way on the right have children C, and then they have only right node child. So we assume that. So at first we gonna sorry tie. Okay, let me check. So we have to create our node. So let me create our node root. So to customize, so we're gonna have to create node. Okay, are gonna be class and then have construction. We accept value, and then we're gonna declare this as value and accept to val. So it's gonna be our root, and we're gonna have left is set to no in case if we don't have any node on the left on the right. So we gonna have right node is set to no, and as follow here, I'm gonna declare variable a and set to new node and pass a. And going through that, I'm gonna create another node. Okay, B, C, D, E, F, and let's check A, B, and gonna be C, D, E, and F. Okay, A, B, C, D, E. Okay, E, F. Okay, and then we can set A dot left, right, from the picture here. A dot left is set to B, and A dot right set to C, and B dot left set to D, and B dot right is set to E, and C dot right gonna be F. Okay, so what we have here, we already have declare function and take root and target. So what we want to return, right? If we found target in our node binary tree. So we want to return all the values on the path where to go to the our value. So let's say here, right? We have we path target E, right? A gonna be our root, and then we going to find E. If we found E, what we want to return is like A, B, and E, right? So what we're gonna do here, we're gonna do like on the root and check to the left first because I want to solve problem with left first. So we're going to go to the left first, and then we go to D on the left, and then we if we don't found it, we return, and then we go to another way, another path, and then if we found a target, and then we return all together. and then return at array. Okay, for doing that, I'm gonna solve this problem by using recursion. So we're gonna have our base case, right? That's an recursive case. As we know, we're gonna do in recursive. And we know our base case, at least we have, if our root is no, this one we just return no. No, okay. If our root don't have anything, we're gonna return no because not have anything to return. And the next base case, we're gonna check if uh, this is gonna be our base case, right? If root value doesn't like if we have only one node and then we pair target, right? And then we already match with the first root, we just return the array with the target. So if root value is equal to target, so we return we're going to return array with root and this value, or like we can return target. That's the same things. And because as I say, we going to solve this problem with depth first. We're going to on the right first, on the left first, left side first. So um, recursive case, we're gonna call each time on the left and the right. So I'm going to uh, create a variable, declare a variable which gonna return left, go to left first, right? Left path. And we're gonna call the function recursively. Sorry, this one. Oh, I think I should move this to here. This is gonna be other. So this one, another one. Okay, we're going to call pathFinder function recursively and pass um, the values of the current values of the right, the left side, right? Path left uh, value, left value, and target, and that we choose return, and then we're gonna check if we didn't find any nodes, we're gonna return all the rest of the path, like where we're going through, right? So let's go to check if we left path. If left path is not equal to no, we return uh, the rest of left current and left path. Okay, PATH. Okay, so we also gonna do the same thing with the right path. So this here I'm going to change to be right. Okay, so and if this both recursive call doesn't find anything, we're gonna just return no at the prompt say. Okay, that's what I should say. So red, I already have pseudocode and right jump to the code. Okay, every shape root at the value equal to target. That's what we target target. That's what we're going to return root dot value. That's what we return, just the one value. If we pass only one node and then we met with the first one. Okay, first root. On here, as I say, I'm gonna declare left path, and we're going to call the function. And what we're going to pass here, we're going to pass the values and the rest of the left side where if we found it, right? So we're gonna use spread operation and we say left path. Okay, and then oh sorry, this one not. We're going to uh call the path pathFinder recursively by passing the root and right, sorry, loose and left value, go to left, right? And then on this one, then another one, we're gonna pass the target, if we found target, right? So it means each core, like stack core, they're gonna go through the left side. Okay. So and then what we're gonna do here, we're gonna check if left pass is not known. That's what we're going to return. So we return the root dot value. That's the current one, the current we found, and then the rest of left path. And actually, I just gonna copy here. We're gonna do the same thing with the right path node. So, but we will change to be right. Okay, and that we path to the right node recursively, and then we're going to check if right path is not known. That's what we're gonna return. The same one too, but that's gonna be on the right node. Okay, so it's gonna be root and value. Oh, sorry, yeah, this and value, and this and wow, and then dot. Right path. That should be work. Let me try to run. So if this code is correct, that's what we're going to return, right? Okay. If we pass E, okay, let me just create another test case. If we didn't pass anything in here, if we cannot find like A, B, C, D, okay. So because I say, okay, let me change this one to be all lowercase C, D, E, and F. And let's say if we pass A, so we found the first one, right? This one should return the array with contain only A. And otherwise, if we pass another one like O, that we cannot find anything here. So this one should return no. So let's run code and see if that works as I expect. Just should be returned. Okay. Okay, sorry. This one I should comment. Oh, sorry. I think I should copy here and paste it here. Just make confused. This is gonna be other function which I'm gonna do. So this one should be tab. Okay, call the function. Let's run again. Okay, that's perfect. So the value return as I expect. So our code is working. And for I already do this here, like for time complexity and space complexity. Actually, this one, yeah, because we run recursively each time, so the stack should call like n square because we use stack and then return each time, and then because space complexity is that we go through every node to check the value. So space complexity and time complexity should be over n. So this one should be over n. Okay. Thank you so much. Let's see another problem later. Bye.